In this video, we're going to take a look at several different quadratic word problem types and see how to set them up. The first thing that you want to do is to read the problem to identify whether or not it's going to be a maximum minimum problem or a find the roots problem. That will allow you to figure out, are you going to be completing the square as part of your solution process, or are you going to be looking at factoring or potentially using quadratic formula to find the roots? In our first question, we're asked to find the minimum product of two numbers whose difference is 8. The key word here is minimum. What that means is that we're trying to find a minimum value on the graph, which means locating the vertex and completing the square. In order to set up this word problem, the first thing that we want to do is to define our variables. Sometimes that's the most difficult part. So think of an example. If the first number was 3, hopefully you could tell me the second number might be 11. 3 plus 8 gives us 11. If the first number is 4, hopefully you can tell me the second number is 12. 4 plus 8 gives us 12. So if x is our first number, then hopefully you can tell me that x plus 8 has to be our second number. The next thing we want to do is set up our equation. We're asked to find the product of two numbers. How do we find the product? By multiplying the two numbers together. So we're going to define the product, p of x, as x times x plus 8. We're multiplying the two numbers together. And that's all there is to it. Now I can expand and put it into standard form, and then complete the square to find the vertex. The y-coordinate of the vertex will be my minimum product. In our second question, we're looking at a revenue style problem. Last year, tickets for some event were sold at $11 per ticket and 400 people attended the event. This year, the organizers would like to increase the price by $1 increments. For every $1 increase in price, 20 less people are going to attend the event. What is the ticket price that will give the maximum revenue? Again, in this question, we're asked for a maximum, so that means that we're going to have to complete the square and eventually find the y-coordinate of the vertex. But before we can do any of that, we have to set up our model. Revenue is defined as the price per ticket times the number of tickets sold. Last year, $11 per ticket was the cost, and we would multiply that by 400 people attending the event to get the revenue. If we increase the price this year by $1, we're going to end up with a price per ticket of $12, and our number of tickets sold is going to be 400 minus 20 times 1, because for every $1 increase in price, 20 less people are going to attend the event. So our revenue then is going to be $11 plus the change in the price times 400 minus 20 times the amount that the price has changed by. So in general then, if x is the change in the price, then 11 plus x is going to be the new price. The number of tickets sold will be 400 minus 20x, and our revenue is going to be 11 plus x times 400 minus 20x. So now I can set up my model. I'm going to let x represent the price increase in dollars. And my revenue, R of x, is going to equal 11 plus x times 400 minus 20x. Our last question involves perimeter and area. This question is also a max-min problem because you'll see that the word maximum is showing up again in the question. This means that eventually, in order to solve this question, we're going to have to complete the square and find the vertex, and find the y-coordinate of that vertex in order to find the maximum area of the garden. A garden fence is to be built with 70 meters of fencing. One side of the garden runs along a wall, so no fencing will be required on that side. I have a fence that's 3 sides, I'm going to let the width of that fenced area be x, and the length of the garden is going to be called length for right now. How do we find the perimeter? Well, if it's only 3 sides, x is the width. If we add up all 3 sides, we'll obtain the perimeter of our garden. We want to know what length is in terms of x. We know that we have 70 meters of fencing to work with. So 2 x's plus the length has to use up 70 meters of fencing. So the length then has to equal 70 minus 2x. So we're going to replace length in our picture with 70 minus 2x. Now we're asked to maximize the area of the garden. So we are going to set up a statement for the area of the garden. Area is found by looking at the length times the width. So A of x is equal to the length, which is 70 minus 2x, times the width, which is x. I can then expand that and complete the square to find the vertex. I need to remember to define my variables. Let x represent the width of the garden. So when you're setting up these word problems, make sure you've defined what your variables are with a let statement. You've used a diagram or example to help you set up an equation. You've solved that equation or completed the square to find the vertex. And your last step is just to include a therefore statement as a conclusion.